So most of us are thinking of AI completely wrong, and we treat it like a fancy chatbot to write emails or generate pretty pictures with, while we continue to drown in routine, soul-crushing administrative work. But what if I told you that there is actually a way that your entire job isn't just a single monolithic job at all? It's actually a series of repeatable intelligence tasks. And by rebuilding these tasks into high-speed glass box pipelines, you can actually automate them entirely. Today, I'm going to show you how I took my own monthly tasks, deconstructed them, and built a transparent digital fleet that runs 1,000 times faster than me for a fraction of the cost. So this is basically my administrative grind. And what I did is that I mapped out every single activity I do in my office on a monthly basis, down to the minute, just to understand what I do, when I do it, and how much time it actually takes me to do it. So if you look at these numbers, I spend 72 hours assessing the quality and pricing realism across different platforms. This is within a real estate field where I have to look at the price realism of various listings that we are running. Another 24 hours is spent chasing developer agreements and onboarding documentations. So basically what I'm doing is just acting as a human router and taking a file from one system to another, reading it, copying it, and moving that information and posting it into another system. Now this is the manual grind, but notice how I categorized this. I wasn't really looking at my job anymore. What I started looking at is discrete atomic tasks. And if you want to escape this grind, the first thing that you must do is to be able to separate what actually requires intelligence from what is just raw computation. So here is where 99% of people fall into the automation trap. They get excited about AI and they try to make a language model do everything. They write a massive fragile prompt which they expect to actually query databases, clean Excel files, do the mathematical equations, and all at the same time sending emails. That is actually a recipe for disaster, hallucinations, and massive API bills that you really want to avoid. And the golden rule for me was never to waste what can be done using computational code or mathematical calculations by giving it to an AI model and I expect it to reason over that. A Python code, for example, is fast, is 100% free, and it does not need any payments. It should be able to handle your math, your sorting, and your data movement. AI, on the other hand, is expensive and it's variable, and it's a reasoning engine. You should only use it when a task requires subjective human level pattern recognition or reasoning. So now let's see how we actually route this. So this is our cognitive filter gate in action. So I want you to imagine a massive influx of partner compliance files. Instead of feeding all that raw data straight to an LLM, our system uses a lightweight Python script first. And that code will immediately sanitize the documents, extract structured metadata, run the filters that it requires to run, and check for any database matches. It will handle 90% of the heavy lifting instantly and perfectly. And only when a file contains complex subjective anomaly, like a flagged discrepancy in a supplier agreement, does the script package that specific context and hand it off to an AI model for the reasoning parts. By filtering the data fast, we protect sensitive information and reduce the token cost by over 80%. All of these, including keeping the AI's focus razor sharp on the few tasks that genuinely require the cognitive reasoning. Now, to actually build this, you have to map your intelligence pipeline. And an intelligence pipeline is simply a sequence of these cognitive tasks or nodes, if you like. Think of it like a physical assembly line, but for information. In our system, every task has a strict unbreakable contract, and the output of task 1 becomes the direct clean input for task 2. So like the example over here shows, if task 1 is an identity check, its output is a binary yes or no answer. And task 2 only triggers if it receives a yes answer. By keeping these tasks isolated, we eliminate the complexity of black box agents, which you don't see what's actually going on inside there. And if a step fails, you don't have to rewrite your entire system. You know exactly which node broke and why its inputs were wrong and how to actually fix it as well. But you must be wondering, like, how do you actually orchestrate these without setting off security alarms? And most developers will choose to use complex, opaque software frameworks that hide data in hidden databases or cloud memories. And for me, I found that using this methodology called the Interpreted Context Methodology, or ICM, does something revolutionary to your workflows. It replaces complex software orchestration with a simple folder structure on your computer, and your entire pipeline becomes a simple series of numbered folders. So this makes plain text our entire interface. And the output of stage one or task one is literally written down to a markdown file, which becomes the input of stage two. This becomes a glass box workflow where you can see everything that is happening as it happens. Anyone can simply open a folder, read the plain text markdown, and see exactly what the AI did at every step of the way. Now, every single folder on our Glassbox factory has a local contract file called the context.md file. And this file basically represents the procedural memory for the specific task. It contains three distinct sections, which are what specific files the agent is allowed to read, the exact cognitive steps it must perform, and the precise markdown format it must write to the output folder. Under the ICM's layered context loading, we only feed the AI model the instructions and the reference materials it needs for that specific folder. We don't want to bloat the prompt with rules from other stages. This selective context prevents the model from experiencing information overload and practically eliminates hallucinations and ensures that the agent acts as a highly disciplined, predictable specialist. Now, when an AI agent starts using tools like, reading files, checking schedules, or drafting emails, it's like a powerful wild horse, and if you just let it run free, it will get stuck in infinite loops, make mistakes, and maybe rack up a lot of bills that you are not expecting. What you need is an agent harness to actually control that system and manage the model by equipping it with three memory systems. Now, I mentioned before procedural memory, and this is where it comes into play, and this is memory for its rules. And we also have memory called semantic memory for durable facts. And we also have episodic memory to track its historical timeline. So it knows what it did, for example, last week or yesterday at 5 p.m. Most importantly, we build a physical end loop guardrail. The agent can run, analyze, and draft, but it cannot hit send or commit data to a live database without a human in the loop checkpoint. You remain as the main pilot, and your AI agent simply becomes your high-speed co-pilot. Now, you might be wondering that once your pipeline is running, how do you actually measure your success? Now, what I use is a metric by Daniel Misler called the KISAC. This metric is basically broken down into knowledge, intelligence, speed, accuracy, and cost. In my old workflow, I have to stop when I hit a certain bottleneck. I just added these numbers as a comparison of what I could do as a human and what the AI plus the code can do as an AI digital fleet. So basically, if I hit a bottleneck of 29 files per day, I'm already fatigued, and I would have an error rate of around 11% due to the fatigue and maybe due to lack of attention. By scaling to a digital pipeline, I'm able to scale this number by 1,000 times. And I'm not just saying this just for the sake of saying it. I believe these are numbers which are very, very achievable using AI. The accuracy would also climb from like 89% to 95% because code assisted AI doesn't get tired, and the cost to actually run this drops significantly. Now, this is the power of building a digital fleet. You aren't just saving time, you're unlocking a massive latent demand and scaling your output to levels that were physically impossible for human labor to do alone. Now, the era of the routine administrative grind is honestly coming to an end, and every repeating cognitive task in your business can and should be automated. If you're someone who is ready to stop acting as a human router and start building your own digital fleet, I want to help you out, so feel free to reach out, feel free to drop a comment with any questions that you may have. I've also compiled my exact workflow audit checklist into a downloadable template so you can start identifying your own code versus AI tasks today. And if you want that as well, just comment code versus AI and I'll send that over to you. Thanks for watching and see you in the next video.